Welcome back students. Now I will explain the NFA to DFA conversion without epsilon. Okay. So this question they may give one transition table or transition diagram without epsilon terms. Here some phi's may be available but there is no epsilon term. Okay. So this is one NFA. You have to convert to the DFA without the epsilon. Okay. So if they given transition table means you have to convert with the transition diagram. If they given transition diagram means please convert into the transition table. So you can check here it can be represented with some arrows. So arrows represented as a starting state. So P is the starting state and S can be represented with a star. So S is the final state. Final state you can represent with a double rounded bracket in the transition diagram. Then you can make the connection. P get the input 0 where it will be go. P get the input 0 it will go to P again Q. So you can draw like P get the input 0 it will go to P again it may go to the Q. Then you can check P get the input 1 it can go to the P. P already get the input 0 it may go to the P. So you can add again 1. So if you are connected with again 1 states or better you can separate like commas. Next Q get the 0 where it will be go. Q get the input 0 it will go to R. Q get the input 1 it will go to again R. So same states. So you can separate like the commas. Next R get the input 0 where it will be go. R get the input 0 it will go to S. So it is 0. And there is no connection between R and the input 1. So there is no need to connect anything. Okay. Next is S get the input 0 where it will be go. Again S. So 0. Again same state with the input 1. So 0 comma 1. So first you have to draw. Next you can check what is your starting states. You can process with the starting state with the input, all the inputs. Okay. So process starting states P and you can process with 0 and 1. So 0 process with the P where it will be go. So if you are processing with a 0 it can go to P as well as Q. So you can mention P and Q. So you can check P and Q is there any states in your diagram. So P and Q they are having separate states. There is no merged states. So you can represent this is the new state. And next P process with the 1 where it will be go. P process with the 1 it will go to P only. P already we are having the states. So this is old state. Next what you have to gain the new states. So you can process the new states with the same inputs. Okay. So here I got P comma Q. So you can process with P comma Q with the input 0 as well as P comma Q with the input 1. So P comma Q with the input 0 means normally if you are having one state with one input means you can check whether it will be go any the states. Okay. Here you are having two states with the combination means you can use separate using the union operation. So P comma 0 union again Q comma 0. Okay, so I can merge using union. So again you can check P with the input 0 where it will be go. P with the input 0 it will go to P comma Q. So you can write P comma Q union. Q with the input 0 where it will be go. Q with the input 0 it will go to R. So this is R. So if you are merged with that you got P comma Q comma R. This is the one new state. Next you can check again the repeated same P comma 1 Q comma 1. So P comma 1 you got P union Q comma 1 you got R. So you got now P comma R. P comma R there is no new states. So this is also one new state. Okay. So next here you got two new states. I think I processed P comma Q with a 0 comma input 0. So you can check again next P comma Q comma R with the input 0 comma 1. Again next state P comma R with the input 0 comma 1. Okay. If you are processing with that you can separately like using union operations. Here you got P comma 0. If you are processing with the P comma 0, you got P comma Q. So if you are processing with the same, you got some answers. So you can write the 4 answers. If you are processing with the P comma Q comma R, you got PQRS. Okay, you can check individually. So you got P comma Q comma RS. So this is also new states. Okay, so next, if you are processing with the P comma Q comma R with the input 1, you got PR only. So PR already got in the new state, so this is the old state. Okay, so here you got one new states, you can write and that new states with the input 0 comma 1 in the next step. Okay, so if you are doing P comma R, here you got P comma R, so that step. Okay, so P comma R with the input 0, you got some answer. I think you got like PQ. Yes, okay. So PQS also is this the new state. And if you are processing with the PR with the input 1, you got P. P is the old state. Okay. So next, PQS you have to process with the next step. Okay. So you can write process with the PQS with the next step. So I will write first to do with the PQRS with the input 0. If you are processing with the PQRS with the input 0, you got PQRS only. So PQRS already processed, so this is the old state. Next, PQRS with the input 1, you got. If you are processed with the PQRS with the input 1, you got PRS. PRS, there is no state, so this is the new state. So new 2 states you got. So this states you have to process with the step 6. This state you have to process with the step 7. Okay. So I am writing in the step 6 and step 7. Step 6 and step 7. Okay. So I am writing with using the union operation. You can write like that. So you can process with the P comma Q comma S with the input 0. You got some answer. Okay. So I think you got PQRS only. So PQRS is also the old states. If you are processing with the PQS with the input 1, you got PRS only. So PRS also is the new old state. So already we processed. So this is PRS we have processed like here. So this is old states. Then you can process with the PRS with the input 0. You got PQS. So PQS also old state. And if you are processing with the PRS with the input 1, you got PS. PS only be the new states. So here you got only one state new states. So I am writing that is in the 8th step. So PS with the input 0, you got some answers. I think you got P comma Q comma S. P comma Q comma S already we processed, so that is old states. If you are processing with the P comma S with the input 1, you got P comma S. P comma S also the old states. So I think all the new states can be processed. So here the steps ended. Then you can write the transition table and transition diagram. That is only. So for the transition table, you can write del 0 and 1. So what are the states you have processed? What are the states you got in the new states? Okay. So P, PQ. So this is all the what are the new states you got. So all the new states you have to write in this del. So then you can check P process with the input 0, where it will be go. Pre-process with the input 0, it got P comma Q again P. So you can write like P comma Q again P. Then you can check P comma Q with the process 0, where it will be go. P comma Q process with that, you can got PQR. So the same PQR. So all the states you have to check and write. I wrote all the states combinations, so you can check. And one or more point. So what is the starting states? P, okay. And what about your final states? So here you got final states, yes, isn't it? So what is your final state? So yes is the final states. So what are the states you have? Yes with the term in the del. So here you got yes, here you got yes, here you got yes, here you got yes. So all the terms you have to mention the final states. Okay, so these are all the final states. Then you can convert the transition table to the transition diagram. So you can first draw all the states in that. So this is also the final state. So final states you can round it with a double rounded bracket. Okay, then you can check P with the input 0, where it will be go. P with the input 0, it will go to PQ. So you can write, draw with like 0. Okay, then P with the input 1, where it will be go again P only. So you can draw like here 1. So you can make the connection using the transition table. Okay. I completed all the transition connections. You can check. Okay. So this is the final DFA. Thank you students. I hope you all understand. We will see in the next video. Bye.